Consider the derivative function f dash x is equal to x e to the x squared. We want to determine the second differential evaluated at 1. So we need to differentiate the first differential. Now, this is a product. So if we say that u is equal to x and v is equal to e to the x squared, then du dx is equal to 1 and dv dx is going to be, use the chain rule, it will be e to the x squared, but we need to multiply that by the differential of the inside function, so that's going to be 2x e to the x squared. And so our f double dashed of x is going to be v du dx, so that's e to the x squared, so that's e to the x squared times 1, plus u dv dx, so that is going to be x times 2x e to the x squared, which would be 2x squared e to the x squared. And therefore f double dashed of 1 is going to be e to the 1 plus 2 times 1 squared, so that's 2 times e to the 1, so that's just 2e. So altogether, that's going to be 3e. Explain the meaning of your answer to part A. Well, if f double dashed 1 is positive, that would imply that it is concave up. But specifically, it is the rate of change of f dashed when x is equal to 1. Determine the expression for y equals f of x given that it intersects the y-axis at the point 0, 2. So now we actually want to integrate. So our f dashed was x e to the x squared. So f of x is going to be the integral of that. Now, if I write it as a half, the integral of 2x e to the x squared, we now have an integral that is of the form f dashed x e to the f of x. So the f of x here is x squared, and if you differentiate that you get 2x, and that's where the f dashed comes in. Now whenever you have that, it's just going to be e to the f of x plus a constant. So this is going to be a half e to the x squared plus a constant. Now we're given that when x is 0, f is equal to 2. So we've got 2 is equal to half of e to the 0 plus c. So 2 is equal to a half plus c, which means that c equals 3 over 2. And therefore our function is going to be half e to the x squared plus 3 over 2.